Hi everybody. Today we will talk about especially the behind the subject of chemistry. Today we will talk the related to our research topic is NTA, means nanoparticle tracking analysis. What is the nanoparticle tracking analysis principle, and what is the main thing of these techniques we will discuss today in the class. You can see the first one, the NTA nanoparticle tracking analysis is a method for visualizing the analyzing particles in liquid, especially in the liquid, and to relate it to rate the Brownian motion to the particle size. Especially the particles in a liquid state, the particle always will move from the zigzag system, that is called the Brownian motion. That particle size will be measured by the NTA, that is visualizing the capture of our CCD cameras. So the rate of movement is related only to the viscosity and temperature of the liquid. It is not influenced by the particle density and refractive index. So this point is very important. The rate of movement is related to the viscosity. If you say that take one beaker and you can see pour that water, it is depending on the viscosity and the temperature, the particle motions will be seen in that solution. So that is not influenced in the particle, especially in density and refractive index. And you can see the nanoparticle tracking analysis allows the determination of a particle distribution profile of a small particles with a diameter of approximately 10 to 1000 nanometers in liquid suspension. Especially nanoparticle tracking analysis allows the determination of a size distribution, especially in the small particles like diameters approximately 10 to 1000 nanometers. We can measure from using of these techniques, nanoparticle tracking analysis. And next one slide, you can see the both dynamic light scattering measurement, means DLS, and the nanoparticle tracking analysis measure the Brownian motion of a nanoparticles, those whose speed of the motion or the diffusion constant dt is related to the particle size through the Stokes-Einstein equation. Especially you can see that the molecules or the particle size will be mostly nowadays are using, especially in research, the DLS and NTA. DLS means dynamic light scattering techniques, and the nanoparticle tracking analysis both are used to measure the Brownian motion of the nanoparticles in suspended motions, that is called diffusion constant, that related to particle size through the Stokes-Einstein equation. You can see that x y squared by 4 dt is equal to kbt by 6 neta d. So here you can see that where the dt is the diffusion constant, product of diffusion coefficient d and the time, and the kb is the Boltzmann constant, t is the absolute temperature, neta is the viscosity, d is the diameter of the spherical particles. Okay, so this is that equation for the determination of particle size by using the Stokes-Einstein equation. You can see here the especially one of the para, you can see detail, the when the particle size is dispersed in a liquid, the particles moves randomly in the all direction. If you take one beaker of water and you can see the clearly how the particle movements, you can see the all directions. The liquid is also termed continuously phase and can be in water and organic solvents such as the 70% ethanol. The phenomena of random movement is termed diffusion and is expressed by the diffusion coefficient d. In more details, the directed migration in given particle is caused by energy transfer from surrounding water molecules to the particles. So the theory of the determination of diffusion coefficient was developed from the famous physicist Albert Einstein. In these options of any concentration gradient within the dispersion and upon long-term observation, the distance small particles moves in any directions should neutralize each other over time, leaving a total movement of almost zero. So however, during even the time interval, the diffusion particles move within certain volume of elements. So this is the main theme of the nanoparticle tracking analysis. You can find out the diffusion coefficient methodology, how these solvents and organic molecules and how the water molecules, you will see that density and the functional theories, how this will be worked out. And especially you can see the different particle size analysis techniques. Nowadays you can see that there are the mainly 4 techniques, the particle size analysis techniques available to measure the size distribution of particles, including the following: laser diffraction, dynamic light scattering, image particle analysis. Image particle analysis, the best example is TEM, tunneling electron microscopy, acoustic spectroscopy. So these are the 4 major techniques to determination of particle size. You can see that dynamic image analysis is 0.8 micromolar to 8 millimolar. And next one, you can see the static image analysis 0.5 micromolar to 1500 micromolar. Laser diffraction 10 nanometer to 400 micromolar or 2000 nanometer. Dynamic light scattering is up to 6500 nanometer, and you can see the 0.8 nanometer to 6500 nanometer. Squeeze analysis 20 micromolar to 125 millimolar. So these are the particle size, different techniques, and what is the minimum to maximum range to measure the particle size. Now you can see here mostly that nanoparticle tracking analysis, this motion is analyzed by video and individual particle positional changes are tracked in 2-dimensional from which the particle diffusion is determined. Knowing the dt, the particle's hydrodynamic diameter can be then determined. So this is that you can see the microscopy and the sample cells containing particle suspension, and you can see metallized surface and glass layer. This is the scatter laser beam and laser beam. This is the equation, the Stokes-Einstein equation. This is the figure. Next we can see that overview of the NTA, how that these are arranged in the overview of NTA method using the particle tracking analysis instrument. The sample prepared by and inserted into the instrument. The NTA software is opened, recording the parameter for the adjusting the sample focusing. Then the data is recorded, focused and displayed. You can see that the sequence of this is that instrumental setup. You can see that power cartridge of system, and this is the sample, the cuvette, and you can see the insert of the cuvette in this system, in this instrument, and you can see this is that signal viewpoint and focusing of this one and recorded and the processing adapter. Then after the you can see the display the result. This is the schematic diagram or proposed schematic diagram of the NTA. Next one, you can see the NTA, the graph will be the x-axis, you can see the particle size, and against the y-axis the concentration of the solution. And this is that Brownian motion. There is, you can see that clearly what is the difference between Brownian motion and non-Brownian motion. So Brownian motion, there is no particular direction. This looks like a zigzag system. You can see these two, and you can see the directional motion is a particular direction. It will be moves from center point to towards the particular direction. This is that there is no center point, that is called as Brownian motion and directional motion differentiation. You can see the next one, the particle size by Brownian motion nanoparticle tracking analysis using of these techniques or using of this Stokes-Einstein equation. This is that gold nanoparticle 400 nanometer. You can use this formula, you can find out the particle size, and you can see this is the figure of schematic diagram. Earlier also you will see in this slide, you can see here clearly microscope and a particle suspension in the liquid, then after laser beam, then glass and metallized surface, and particle scattering from the laser beam. This is also the schematic diagram I was showing here that clearly, and you can see this is the atomic force microscopy, that AFM. You can see unknown nanoparticle sample can be characterized by the mainly these 3 techniques nowadays people are using familiar. You can see atomic force microscopy also, you can find out the nanoparticle size, and the nanoparticle tracking analysis is the another one techniques. The next one is the DLS, dynamic light scattering light intensity by time. So this is the main 3 techniques, or you can use the nanoparticles, you can find out the size. One is the atomic force microscopy, nanoparticle tracking analysis, NTA. Next one DLS, dynamic light scattering. Okay, and you can next one you can see this is that laser and the channel of cross section and microscopy, video camera, and the zeta focus and the size, concentration and zeta potential. This is another one diagram. You can see here the clearly the picture how that instrument will be set up in a measuring of the data analysis particle size. This is the, and this is that concentration by dilute particle per centimeter, NTA and the DLS. What is the differentiation? Measure the concentration particle per centimeter in inverse. The NTA you can nanoparticle tracking analysis, the minimum range to maximum, and the DLS is the here to here. You can measure this one. This is picture easily understood these things. And next one, this is the picture of the Brownian motion, how this is the zigzag system, the particles are moving in that image. Next one, see the negatively charged particles of center one, that is next one stream layer and the slipping plane. These are the zeta potential. What is zeta potential of this one? You can see that zeta potential of is between the stream layer and the slipping plane. That between it is called the zeta potential. Okay, positive and negative charge of the negatively charged particles. And next one, you can see clearly what is that interaction of incident light with the particles and surface of the molecules, are simply you can say solution. If you see that this is the light source, if you light source it will falls down into the particular molecules or the solution, it will be reflect the backside, that is called reflected. Next one is the, if you pass the light will be absorbed completely in the molecules or the solution, that is called absorbent. Next one is the refracted. You can see past that light, you can some of the light will absorb, then remaining light will become out, that is called refracted. Then the next one is the diffracted. Diffracted means most of the light will completely come out by the changing of the curve. So this is the mode of interaction of incident light with particles and surface. Light with the particles and surface, that is that image you can find out. So if you really like this video, please like and share and comment and subscribe to my channel. Thank you very much. Especially this topic of NTA nanoparticle tracking analysis is mostly useful in the who are doing in research, especially in biophysical chemistry and the physical chemistry, and most of the multidisciplinary subjects people in really need to measure the particle size and particle things. These people use the nanoparticle tracking analysis method. Okay, and you can see this next class we will go through detail what are the biophysical techniques specially used for to measuring the particle size and molecule size. We will discuss in briefly that's all techniques like DLS, dynamic light scattering, and the nanoparticle tracking analysis. And next one you can look for the SEM and TEM and AFM atomic force microscopy. These techniques we will be go to very clearly in the next class. We will go to the detailed information by methods and principles, these things. So nowadays, especially in research area, that particle size measurement is the big challenging, and year by year, and the technology is updated, and particle size also will be measured by the advanced instrumentation techniques using our advanced instrumentation technique. So these techniques are the, I think these nanoparticle tracking analysis mostly used for that biological sample preparation in cosmetic industry and medicinal field and pharmaceutical industries. And especially in biological peoples, they will use for the nanoparticle tracking analysis how the particles are moving into the solution and what is the particular size in depending on the time, how the size is enhancing or the again compressing. Those studies specially will be using of this nanoparticle tracking analysis. We can understood the clearly. And another thing is best ideology of especially these nanoparticle tracking analysis mostly use the people for the biological samples measurement things in sample. Okay, so anyhow, thanks for watching my video. Thank boys. See you. We will meet you next class with some ideology of what are the techniques nowadays available in the research, especially for the measuring of the particular size of the molecules or particular size of the particles, especially like NTA, DTA and DSC, and like thermal studies and temperature how will affect on these things. Thank you, bye, see you. And if you like this video, like, share and comment. So don't forget to subscribe my channel. We will see the update in soon, and